if I'm using the roots, the zeros, or x-intercepts to determine what the quadratic function is? Well, the first thing, Nathan is determining the quadratic function represented by the graph in the diagram, and he recognizes the x-intercepts as -2 and 6, here and here. And he says that the function is f of x is equal to x plus 2 times x minus 6. And it tells us another point that lies on the graph, 3 and 30. Well, when I substitute this in, if I said f as a function of 3 is equal to 3 plus 2 times 3 minus 6, replacing the x with 3, then when I actually multiply this out, I actually get -15. But it says that my y value should be 30. So does it lie on Nathan's graph? No. 3 and -15 lies on Nathan's graph. When it says what did he not consider when he made it, he did not consider the a value, which changes the shape and direction but not the x-intercepts. So, if I want to determine how to find the correct function, then I'm going to take the other point that I know exists. It says clearly that 3 and 30 exists, and I'm going to replace y with 30. I'm going to replace the x's with 3, and I still know that there's an a value I'm going to have to solve for. So I would say that 30 is equal to a bracket 3 plus 2 times 3 minus 6. Or 30 is going to equal a times, we already multiplied this out, -15. A would equal 30 over -15, which is going to be -2. And now that I know the a value, I can write the proper function. The proper function for this would be f of x, or y, is equal to -2 bracket x plus 2 and x minus 6. Now, in this case, a quadratic function in the form of ax squared plus bx plus c has zeros at 4 and -8. If the point of 1 and -9, there's my x value, there's my y value, is on the graph, determine what the function is. So first, I'm going to use my zeros to determine the factors, and I would say that this would be f of x is equal to a bracket x minus 4 and x plus 8. Now I can use the -9 for the y is equal to a bracket, and I'm going to replace both the x's with 1. Or -9 is equal to a times -27. And I'm going to divide both sides by -27. Well, if a is equal to -9 over -27, this is going to be the reduced fraction of 1 over 3. Then I can put my a back into this equation and say that f of x is equal to 1 over 3 bracket x minus 4 and x plus 8, or f of x is equal to 1 over 3, when I FOIL this out, bracket x squared plus 4x plus, sorry, not plus, minus 32. Or f of x, when I multiply all this by 1 over 3, is going to be 1 over 3x squared plus 4 over 3x minus 32 over 3. And there's my answer. For the last example, consider the function f of x is equal to 6x squared plus 8x minus 14. Well, if I'm going to show how to write the function in factored form using the graph of the function, the first thing is I'm going to find the x-intercepts of the graph. So I would graph into my calculator y is equal to 6x squared plus 8x minus 14. And depending on the calculator I'm using, I'm either going to use the roots function or I'm going to use the zeros function to find that these occur at negative 7 over 3 and 0, and at 1 and 0. I also know from my equation, because this is already in general form, that my constant is the y-intercept. So I can also state that I'm going to have the point of 0 and negative 14. And from there, I can expand out my graph. And it's going to look something like this. Well, I know that from these x-intercepts, f of x is going to equal a bracket 3x plus 7 bracket x minus 1. Or f of x is suddenly going to become, from this coordinate, negative 14, and the x's are both going to become 0. 3 times 0 plus 7 and 0 minus 1. Which means that negative 14 is going to equal a times 3 times 0 is going to be 0 plus 7, and 0 minus 1, or 7 times negative 1. Negative 14 is going to become a times negative 7. So a is going to equal negative 14 over negative 7, or positive 2. In my factored form, f of x is going to equal 2 bracket 3x plus 7 and x minus 1. We can factor this original function and we should get the same result. So first, I would state that f of x is equal to 6x squared plus 8x minus 14. I'm going to pull out the common factor of 2. And I'm left with 3x squared plus 4x minus 7. Then if I'm using my decomposition method, I'm going to multiply the coefficient of x squared and the constant and get negative 21. And I need two factors of that add up to positive 4. In this case, it's going to be negative 3 and positive 7. So I'm going to split that up and say that f of x is equal to 2 bracket 3x squared minus 3x plus 7x minus 7. F of x is equal to 2, and then when I factor by grouping, I have 3x and x minus 1, and I'm going to have positive 7 and x minus 1. What's in the brackets is the same, which means I'm going to take the common factor of 2 is still going to be there. I'm going to multiply it by what's inside the brackets, x minus 1, and then I'm going to group together what's outside the brackets, 3x plus 7. Even though the factors are in a different order, this is the same as this.